Today we are multiplying and dividing monomials. Everybody say monomials.
Monomial.
Okay, monomial is a single term. I need you to write notes fast because we only have 20 minutes.
There's no paper in there, though.
Yeah, I'm out. All right, so I'm going to need you to write notes quickly because we have only 25 minutes and I want to make sure and get through it. And the note taking, just, you got to make sure and go quick. So a monomial is a single term, a group of numbers and or variables tied together by multiplication or division, but separated by addition or subtraction. So a term is a number, right? It's a number. Notice it says and or. It could just be a number. It could just be a variable. It could be both tied together by multiplication or division. We know that the term is over when it's separated by addition or subtraction. Here are some examples. Okay. So they are tied together by numbers and or variables. So notice, every term has a sign, and the sign comes right before it. What is this sign? Is it positive or negative?
Positive.
Positive. If there's no sign, it's a positive. What is this sign?
Negative.
What is this term?
Positive.
Positive. And this one?
Negative.
And this one?
Positive.
Good. Okay, so they're tied together by numbers and or variables. The coefficient is the number preceding the variable. That means it comes before. To precede comes before. So, what is the coefficient in the first term?
-5.
Yep, -5 is the coefficient of the first term. What is the coefficient of the second term?
3.
+3. What is the coefficient of the third term?
4.
Okay, you should be writing now because I'm not going to stop at the end. And what is the coefficient of the next one? -5 over 2. And what is the coefficient of the last term? 1. The other thing you need to know about monomials, it is a monomial if it has a whole number exponent. Their exponents need to be whole numbers. Integer. Integer exponents. Okay? So that's awesome. Can I move on?
Yeah.
Okay. So, on number 1, tell me, is this a monomial or a non-monomial? Raise your hand quietly if you'd like to answer this question. Monomial or not a monomial? Don't all volunteer at once. Go, Elise. Thank you.
It's not a monomial.
Go back to our definition.
Oh, wait, it is a monomial.
It says
Sorry.
numbers and or variables. Is
Sorry.
that a number
Yeah.
or a variable? Yes.
Sorry.
So it is a monomial. That's okay. Everybody said that last time too, and they always say that on the first one. The next one, is it a monomial?
No.
No,
There's addition.
What?
they're separated by addition.
Separated by addition. So the only way it's a monomial is if it's tied together by multiplication or subtraction. See how this is tied together by multiplication? Multiplication, multiplication, division, multiplication. Multiplication or division. It would be separated. So a monomial is one term. This would be 2 terms. Do you see that? The plus or minus sign tells us when one term ends and the next begins. Number 3, is it a monomial?
Yes.
Number 4, is it a monomial?
Yes.
Number 5, is it a monomial?
Yes.
Number 6,
No.
no. Number 7,
Yes.
and number 8.
Yes. No. Wait.
No, because I told you I added that one little piece that all exponents need to be integers, negative or positive whole numbers. Okay? So it's not a monomial. You get the idea? So today's lesson, it's really going to end up reviewing a lot of what we did. It's going to get a little bit more complicated, but it's reviewing everything we've done because it's multiplying and dividing monomials. So notice, here's a monomial, here's a monomial. They're being multiplied together. Monomial times monomial times monomial. Monomial times monomial. Monomial times monomial. Do you understand? All right, so when we are doing our, I'm going to just go through one of them, and let's do 3 times negative 2. I multiply coefficient with coefficient, so it's 3 times negative 2 and a squared plus the second power, so it ends up being negative 6a to the 4th. You got it? Okay, pause the recording, and I'd like you to finish up the rest. And one more time, the song is monomial, do 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 do. Monomial, do 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 do. Monomial, do 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 do. Monomial, do 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 do.
Was my first thought.
Okay, so we are checking our work. So the first one is we're going to multiply 3 times 5, and it's x to the first times x to the fourth. So that would be x to the first plus the fourth power. So it's 15x to the fifth. Number 3, I'm multiplying all my coefficients, which are negative 4, 3, and negative 1. Right? And then I'm going to do m to the second plus the fourth power plus the first power. I see a lot of people today forgetting about this. First of all, forgetting that the coefficient is 1, and second, forgetting that it has an exponent of 1, and both matter. And so when we multiply that out, we get 12m to the 7th. And then the next one, we're multiplying 7 and 3. A is to the first power plus the fourth power. B is to the second power plus the first power. And C is to the first power plus the third power. Okay? And then we simplify it to 21, A to the fifth, B to the third, C to the fourth. Questions? Okay. All right. So now we're going to add power to a power to it. So I'm going to do the first one. Remember, when it's outside inside, we multiply the exponents. Okay, so I'm doing 5 to the third, y to the third, and I do want you doing these in-between steps. And 5 to the third is 125, y to the sixth, and then I get negative 2. Did I do something wrong?
Yeah.
Oh, there we go. Yeah, I did do something wrong. I did 5 to the third. It should be 5 to the second power. So it should be 25. I knew that didn't look familiar. 25x to y to the sixth, and then negative 2 is to the second power, and y squared multiplied by the second power. So it's times 4y to the fourth. Now, I'm going to multiply 25 times 4, and what do we get?
100.
100. And this time, I'm going to go 25 times 4. And this time, what am I doing, Nicole, with y to the sixth and y? Right. Now we add them. So it becomes 100 y to the 10th. Okay, you guys do number 2. Go. I want you to do those in between steps. Pause the recording. Okay, what do I do first?
First, you're going to do 3 to the first times 2. Or just 3 to the
No, we're not doing 3 times 2.
3 to the second power. Sorry.
Good. Second power and C.
To the second power.
Good.
And then you're going to do times negative 2 to the third.
Uh-huh. And C to the...
4 times 2.
Good. And so that simplifies to?
9 c to the second times negative 8 c to the 12th.
So 12. Good. And then, what does it simplify to?
Negative 72 c to the 14th.
Good. You get it? Okay. Kind of putting... Yes, I'm sorry. Hold on. So, and then we're doing negative 72, right? Because I'll do that last step. We're adding those exponents. So it's 9 times negative 8, and c squared plus the 12th. So that makes negative 72c to the 14th. Questions? Okay, moving on. All right, so negative exponents, you don't need to write this. Just listen for a minute. There's two ways to do these. We can, if I have a negative exponent, so I can just right away move it into take the inverse of it. The reciprocal, not the inverse. The reciprocal. I can reciprocate if there's a negative exponent. If it's in the numerator, I move it to the denominator. If the negative exponent's in the denominator, I move it to the numerator. I can do it that way, and then I'm multiplying 81 times 1 over 9. And then we can cross cancel, and we're left with 9, right? Or I can use my integer rule. Either way, it doesn't matter. The integer rule is 3 to the 4th power when I'm multiplying with a common base, right? When we're multiplying right here, isn't the rule when we're multiplying with a common base to add the exponents? Yes or no? Yes. So, in this case, when I'm adding, so it's 3 to the 4th power plus negative 2. Now, my integer rule says a positive times a negative is what? Negative. Right? Positive times negative makes negative. So it's 3 to the 4 minus 2, which equals 3 to the 2, which is 9. Do you understand? So it doesn't matter which way you do it. You can reciprocate it like this, or you can use your integer rules. But what you do need to know is that when we are doing this, multiplying with the common base, it's a positive. It's plus. We add the exponents. As opposed to if I'm dividing with a common base, what's the rule? The integer rule. We subtract we subtract, right? So again, I can reciprocate it and just move that right into the denominator and make that 1 over 7 to the 3rd power, and reciprocate, okay, sorry, it's divided, right? 7 to the negative 2 divided by. Isn't that the same thing as 1 over 7 squared divided by, or multiplied by, you know, what, we don't, remember with fractions, we multiply by the reciprocal. So that's why it's 1 over 7. Do you understand why it is that? I like to kind of think of that, if you're going to do it this way, instead of multiplying by the reciprocal, instead of rewriting that whole thing, I just say to myself, I rewrite the fraction. Does this go in the numerator or denominator? It goes in the denominator because it's a negative, and then once I move it, it stays positive, times 7 in the 3rd, and there's that 1 that's left. So I probably would have done that, which is 1 to the times 7 to the 6th power. As opposed to if I use the integer rule, it's 7 to the negative 2, and this time what's the rule? Minus the 3rd power. And then we get 7 to the negative, sorry, that should be negative to the 5th, negative 5 here. We don't multiply them, we add them, and this one should be to the negative 5. And isn't that the same thing as 1 over 7 to the 5th? So it doesn't matter what you do. You can reciprocate your negative exponents. If they're in the numerator, move them to the denominator. If they're in the denominator, move them into the numerator. Right? Okay, so let's try some. The easier they are, I use the integer rule. The more complicated they get, I just rewrite it with no negative exponents. Does that make sense? That's how I do it. So on the first one, let's use the integer rule because that looks very simple. So what would this be? X to the 5th power. Somebody?
Minus negative 4.
Minus negative 4. Remember, minus because it's division. And so what does that simplify to? X to the, that becomes a positive, to the 9th power. I could have done it the other way. X to the 5th, rewrite it right away and move this up. Times x to the 4th, it makes it x to the 9th. Okay? Right? X to the 5th over x to the negative 4 equals that. Okay? I could right away use the integer rule. This you could be writing if you want some examples. Y to the 4th power. What am I going to do here, Nicole? Since it's multiplication.
We're gonna
Add or subtract?
add 3.
Add negative 3. Now really what that means is y to the 4th power. A positive times a negative is a negative, so that makes negative, right? Those two make a negative. And so that really equals y to the 1st power. The other thing I could do is I could right away rewrite it as y to the 4th times y to the negative 3 equals y to the 4th, drop it down, y to the 3rd. And then I'm doing y to the 4th minus 3rd equals y. So do you understand? You have two ways to do this. Questions? As they get more complicated, I just rewrite. Okay, here, remember I taught you, I just want you to do the slash and dash method, where we are I can't even think of the word right now, reducing. Where we're reducing, what's the greatest amount of A's that we can divide out of numerator and denominator? 3. When I take 3 out of here, what's left? A to the 3rd, I'm left with the number 1. When I take a to the 3rd out of here, what's left? A to the 7th. Are you with me? And so we're left with a to the 7th over 1. I don't need to write over 1. What's the greatest numerical factor I can divide out of number 2? You should be writing these as we go. I can do 2. So Nicole, in the denominator, what's left?
1.
1. And in the numerator, what's left? 4. What's the greatest amount of x's we can divide out?
4.
X to the 4th. So when I divide x to the 4th in the denominator, what's left? And when I divide x to the 4th in the numerator, what's left?
5. X to the 5th.
X to the 5th. Good. And so what's left when I multiply across is 4 times x to the 5th, which is 4. X to the 5th. I don't need to write it over 1. Number 3, why don't you guys pause the recording and try that one on your own? Okay, what do we do? Who wants to do it that I haven't heard from today? How about Mike?
So our divided 6 and 9 are
By what?
by 3.
By 3, and what's left? In the numerator?
2.
And the denominator?
3.
3. And what are we dividing out of the variable?
The most we could divide is 4. So
M to the 4th. Don't say 4.
and then you get m to the 8th.
In the numerator?
You get 0.
No, we do not get 0.
1.
We get any number divided by itself equals 1. And when I divide in the denominator, what am I left with?
M to the 8th.
M to the 8th. And so in my numerator, I'm left with 2 times 1 is 2. And in the denominator, we're left with 3 times m to the 8th. You got it? Okay, you feel okay about these? So when I I wouldn't use the integer rules. I would just use the slash reducing. So on the first one, what's the greatest amount of x's we can take out? 3. I take 3 out, I'm left with 1, and here I'm left with?
5.
X to the, say it properly. X to the 5th. What's the greatest amount of y's we can take out?
9.
Don't say 9. Y to the 9th. So when I take out y to the 9th, what's left?
Y to the 3rd.
No, it's not. In the numerator, 1. And in the denominator,
Y to the 3rd.
y to the 3rd. Thank you. So my new answer is x to the 5th over y to the 3rd. Next one, what can we do? Divide out.
By 3.
In the denominator, what's left?
1.
In the numerator,
2.
greatest amount of a's?
8.
Good. In the denominator, what's left?
8 to the 5th.
In the denominator. In the numerator. Good. What's the greatest amount of b's? In the numerator, what's left? In the denominator? So we're left with 2a to the 5th. Okay, you get the idea? It doesn't matter if it's lower or the same amount. Let's try one more. Well, I think we're good. Okay, let's stop there. Let's keep going. So now let's look at what happens when we have power to a power with negative exponents. We're still using we're going to multiply. We have a negative exponent. It'd be 2 to the what power?
-6 power.
And then that would drop down. That means 1 over 2 to the 6, which would be 1 over 64. Right? Yeah. Do you understand? So still just using those same power to the power with a negative exponent. Okay? And, I mean, this is just another way to do it. There's so many different ways in order to do it in. So here I'm going to get 5 to the 4th power. What are we doing?
You're adding negative.
Plus -2, so that makes 5 to the 2nd power, which is 25. Next one, what am I going to do? 8 to the 2nd power,
Plus 1.
outside, inside,
Times negative 1.
times -1. So what does that make? 8 to the -2, which equals 1 over 8 squared, which is 1 over 64. That's 64. You get the idea? What's the next one? 7 to the what? -6 times 7 to the 5th. Do we want to just drop it down right away, or do we want to, let's use our integer rule. 7 to the -6 plus 5, what does that make? Which equals 1 over 7 to the 1st, which is 1 over 7. You get the idea? Okay, let me go to the next one and see if there's more like that. You can pause the recording and then check your answers. Notice they're multiplying these out. Look at this. These are different bases. They're just multiplying them. Simplify them and multiply them out. Is everybody clear on that? Let's go over this one. This looks a little unique. Number 6. So notice right away inside here, isn't that we're adding them, right? Once I get that, it's 4 to the -2. Then we're going to multiply by the -2 because it's outside inside. Got it? Make it 4 to the 4th, which is 256. All right. So with negative exponents, not everything is always negative. In my fraction, where does the 3 go? Numerator or denominator?
Numerator.
Numerator, and m to the -2 drops down and becomes positive, right? Okay, what goes in the numerator here? Stop. What goes in the numerator? 6x. What drops down? Good. Okay, in here, what goes in the numerator? In the numerator? 1. What drops down? The entire parenthesis. 6 to the 2nd, x to the 2nd, y to the 2nd. That makes 1 over 36 x squared y squared. Okay? Well, we can do y to the 4th power plus -4. What does that equal? Y to the 0. And what does that equal? 1. 1. Anything to the 0 power equals 1. Okay? Hold on. 2 is to the -3rd power. X is to the -3rd power. And y, we have the 3rd times the -3rd power. So it becomes, they're all going to drop down, right? One. Okay, I'm going to go 1.
Or can you simplify it?
We could. I could do 1 over what? What does that become? 2 to the 3rd times 1 over x to the 3rd times 1 over y to the y to the 9th. So that becomes 1 over 8 x to the third y to the ninth. You get the idea? Yep. Hold on, let me see if there's anything on the last one. I think that's... Okay, if we have negative exponents in the denominator, very quickly, again, I would just reciprocate it right away. Rewrite it. The reciprocal would be 3 times x squared. Got it? Let's see if there's any others here. So, something if it's really big, like this. Okay, so like, look at number 4, guys. I would rewrite that as m. Where does 7 go? Stay or go? Stay. X to the third, negative 3. Go. Move up, and it becomes positive. Y to the negative 4 goes up. You get the idea? This would become 1 times 5a squared. The whole thing becomes 5a squared, a squared. 25a squared. Not over 1, right? You get the idea? All right, that's the recording. Oh, we could have done a little bit more. This is just a practice.